Learning how to make your own interactive visualizations is one of the most useful skills that you can bring to a company. So, in order for your analytics to really make a difference at a company, people need to act on those actionable insights that you're providing. And when people can see the analytics in action, they're a lot more likely to act on it. So, one of the main tools that you can use in RStudio is developing one of these Shiny applications. In fact, it's so common that there's a whole website devoted to Shiny, and it allows you a near endless array of possibilities for making visualizations and increasing interactivity between the decision makers and the analytics that's going on at the company. And this isn't just, for fun. You can see a list of professional fans that are using RStudio, that are using Shiny apps, and you're in really good company. We got Walmart, we got eBay, we got Samsung, etc. So what kind of stuff can you make in Shiny? What kind of interactive visualizations am I really talking about? Well, if you head over to the gallery section of the RStudio Shiny website, you can get an idea for what Shiny can do for you. So they have a great gallery of different applications that people have uploaded that you can interact with in various roles like consulting, education, public healthcare, public sector, etc. So let's see a few of these visualizations in action just so you can appreciate some of what you're going to be able to do very shortly. So one interactive visualization deals with COVID-19. This application was put together by a group at a university, and they scrape real-world data from websites that talk about, what's the status of COVID-19 across the United States. You can select to see stuff on a state level, you can select stuff on a county level, and you can even choose date ranges for the dates under examination. You can get predictions for what might happen in the future. And so you can see that this would be a very powerful thing to actually use to just see the progress of the spread of COVID-19. And in fact, you saw the first day of class, my COVID-19 simulator, which was designed to kind of examine what would happen at a 200-bed facility if someone became infected with COVID-19 and started spreading along the social network, seeing how the spread changed from one day to another to see what fraction of the individuals at this facility ended up becoming infected. This was a Shiny app that was put together by Tanner Beasley, a current Master's in Business Analytics student. While he was an undergraduate, he was interested in looking at the popularity of various search terms when it came to job descriptions for data scientists. And so we can input in some search terms like analytics. And it will continue to add to the plot. Python and R were defaults, so we can see how the popularity of these search terms change over time. And we can get some idea of the statistics. We can develop different pivot tables looking at the measures of these search term popularities. You can change the date range. You can change what type of plot you're looking at. You can also change how that trajectory over time is being displayed. Another example, if you're a big fan of pets, maybe you would like to develop an app that keeps track of your pet's medical history. So this app on the gallery looks at two dogs' medical histories, Layla and Lloyd here. And this just shows you some of the things that you can do once you're very advanced when it comes to developing Shiny applications. You can look to see, what's going on with Layla or Lloyd in terms of medical history versus dates, changing the date range here. You can look at vaccination history. You can look at the vet history, etc. Just kind of a running total of what's been going on with these pets here. Another example, this time from sports, this is looking at similarities of various soccer players. So I'm not exactly too familiar with the terms in soccer, but there are various interactive features that you can change with how the plot's going to be displayed. I guess we're selecting different people, gauging to see, who's similar to these individuals. Click Update Filters, and the plot's going to change. So we can interact with this, and we can learn something about the process that we're trying to study here. The gallery is a great place to browse through just to see how people are using Shiny in business and in other fields. So the question becomes, well, how can we write our own Shiny app? Well, actually, if you scan down and keep going farther and farther down in the gallery, you actually get to some useful building blocks of what goes into the more effective visualizations. These Shiny demos give very simple visualizations that allow you to see how they're being put together, kind of the skeleton or the bare bones elements of each of these visualizations, and it helps you build up from there. Now, there's a lot of resources that you can turn to about, okay, what does each part of the Shiny app code do? How do I make the code do various tasks and actions? And there's some great slides and there's some great lectures that you can view on your own time if you think that might be helpful. But my favorite way of learning how Shiny works is just to take a stab at it. So let's learn about Shiny just by getting our feet wet and just doing it. So one great thing about RStudio is that you can always go to File, New File, and then Shiny Web App to get a nice skeleton of a Shiny app that you can modify. Now, when you select this, it'll prompt you for an application name. It's not really the name of your app. It's going to be the name of the folder where it puts all the files. So I'm going to call this example app, and I'm going to say to create this in my Bison 533 folder. So I'm going to create this, and you'll notice that it brings up a file called app.r. That's the name of the file that's going to contain the code for your Shiny app, so you might want to go and immediately just save this as something else. So I'm going to call this practice app.r, and we'll work from this. So let's just click on Run App to see what we're dealing with. This app deals with the Old Faithful data, and I had the good fortune of actually going to Yellowstone and seeing Old Faithful for the first time this summer. It was awesome, and one cool thing about Old Faithful is that from an analytics point of view, it's pretty intriguing because you can predict how long you have to wait for the next eruption based on how long the current eruption lasted. And so this app lets you look at a particular component of the eruption times for Old Faithful, specifically the times between sequential eruptions. That's what's being plotted here, the distribution of as a histogram. Now, not very useful because it's labeled with a generic X. We don't know what that is. Histogram of X. We have the idea of what this app is trying to do, but we'll fix it up. So when we click Run on this example app, well, it just has a very basic demo of an interactive component, the number of bins essentially for this histogram, and then a reactive component, which is updating the visualization based on what the user has been selecting. So this is what we're going to modify or create when we make our own Shiny app. We're going to create a series of user interface elements here on the left that is going to dictate what the plots and output on the right are going to look like. So how does this work? Okay, so when we look at the code of a Shiny app, very broadly, it's going to be split into two components. So we're going to have a UI component, which is going to tell the app what to put over here on the left-hand side, what interactive elements do we want, sliders for the number of bins, a little checkbox for colors, or maybe radio buttons for what variable is being plotted. And I think one great way of actually getting an idea of what can we actually do is looking at the Widgets Gallery. I'm going to click on Widget Gallery. These are the user elements that you can add that allows interactivity. We can add an action button, basically like the refresh, like allow the user to change a whole bunch of things, and then click this button so that those changes take into effect. We can have a checkbox like, hey, do you want logarithmic axes? Leave it checked or unchecked. We can make a checkbox group. We can do date ranges, date inputs. We can do a file input even. We can do radio buttons, have the user input a number, a drop-down box, text input, sliders. There's a lot of stuff that you can add to the plot. And then we're going to have a server part, which is going to be the engine that actually creates the plots and the output themselves. So once again, the Shiny app split into two main components, the UI, which sets up the interactive elements and also puts placeholders for the different apps or for the different plots and the different parts of the output. And then we have a server part of the app, which actually goes and creates those plots and elements here. And then after the end of those, we have Shiny app, which is what actually runs the app. When we click on reload app or run the app, that's actually what is invoking the creation of that plot. So what do each one of these things do? Well, let's start with the user interface. And it's going to look a little bit weird. The code that goes into a Shiny app is a little bit different than the functions, the for loops, the merges, the aggregates, the Monte Carlo simulations that you've been writing. So here's how it works. UI is actually going to be an object that gets created by running the fluidPage function. That's a function that lives in Shiny. There's a few other options for how a page gets created. fluidPage, fluid changes, it's amorphous, it's going to respond to user input. So it's a good name. So fluidPage is going to be a function that takes all of the elements and the descriptions of what we want to have appear in the app and actually sets up kind of placeholders for them in the app itself. If we notice, the parentheses for this function stretch really over quite a long range of lines of code here. Just moving the mouse over this bottom parenthesis, we see that actually everything in between those two parentheses is actually the argument for this function. Now, to get into a little bit more detail of it, there's a bunch of different ways that you can change the layout of your app, where you want the plots to be, where you want the interactive elements to be. This is where all that stuff happens. When you open up the default Old Faithful app, well, it's a good place to really start out with. Here's what we see. We see two arguments to the function fluidPage. The first argument is called title panel. What do you want the title of your app to look like? Right now, it's Old Faithful Geyser Data. Second argument, and notice what separates the first from the second argument is a comma, is going to be sidebar layout. Now, sidebar layout is what's doing the heavy lifting in terms of how the interactive elements and the plots get arranged. There's a lot of other functions that you can use to change how the layout of your app looks like. The examples you brought up at the beginning of the video here showed you a lot of different layouts. That's where all that's controlled. But overall, that's going to be the second argument to this fluidPage function that creates the app. So notice there's actually a lot of stuff that goes inside of sidebar layout. Sidebar layout is actually a function in itself. So yes, we are having as an argument to the fluidPage function, a function in its own right. And inside this sidebar layout function, we actually have two arguments. The first argument is the name of another function that we keep putting stuff in. I told you it's going to be weird looking code that we're not used to seeing when we write our own stuff, but we'll learn how to play around with it. But anyway, in the sidebar layout, we have a sidebar panel which says, hey, what do we want to have as the interactive elements here on the left-hand side of the app? And then we have a second argument called main panel, and that's just setting up placeholders for what we want to see on the right-hand side of the app. The output, the plots, the text output, anything that we want to have displayed that's going to respond to the user input. So that's the UI component, the first half of any sort of Shiny app. It stretches anywhere from just a couple lines to hundreds and hundreds of lines, depending on how sophisticated your application is. And the second part of the Shiny app is going to be this server object that gets created. It's actually going to be a function that we're defining. We'll leave the input and the output as is. But this is the code that actually goes and generates the plots, that generates the output that we add to the Shiny app. So let's give ourselves a series of tasks where we can learn how the appearance of the app is connected with the code itself. So task 1 might be to change what the title of the app is away from Old Faithful Geyser Data. Task 2 might be to change the appearance of the histogram, specifically what the title of the histogram is and what the label is for the x-axis. Task 3 might allow us to allow the user to change what's being displayed. Is it a histogram of the waiting times or a histogram of the eruption times? Right now it's always waiting times. Task 4 might be to give a numerical summary of the quantity being examined, a numerical summary of the waiting times or the eruption time. Task 5 might be to add some helpful labels to add some clarity over what's being displayed. Maybe Task 6 is to add a scatterplot that shows the relationship between the waiting and the eruption times. And Task 7 might be to add potentially a checkbox that allows us to swap the roles of the X and Y axis. So let's see how everything's connected between what we see on the app itself and the underlying code. So task 1, let's try to change the title of the app itself. Well, heading on over to the code, we find that the title of the app is controlled by the argument to title panel. Right now, it's just a text expression called Old Faithful Geyser Data. Let's say Old Faithful Examination. When we make a change, we can reload the app by clicking on Reload App. And I think there's a bug right now, so when it says Save Selected, which we want to do, it's going to come up with an error just saying, hey, error saving file. I think it saved it anyway, but if we just click OK and click Reload, we're going to see that the name of the app has indeed changed. Okay, well, how could we add a bit of clarity to the histogram by changing the title of the histogram and then also the label of the x-axis? Well, that requires us to examine the code that's generating this histogram. And all of the code that goes into generating the visuals you see on the app, that's going to be somewhere located in the server part of the app itself. So right now, the server app has a single, really long line of code that's generating this histogram. It's starting out with output $distplot. Distplot because that's how it was set up as a placeholder when we set up the UI element. And right now, output $distplot is the result of running renderplot. That's what we use to render plots in the app itself. So the argument to renderplot is the whole chunk of code that we're going to use to make that plot, make that histogram in this case. So how is this histogram being made? Well, let's just read the code. It generates a vector called x, which is the result of extracting out the second column of faithful, which is a data frame that R knows about. If we were to just ask, well, what's the first few lines of the faithful data frame, it'll show us the eruption time column, and it'll show us the waiting time column. So it's creating a vector x, which is the vector of waiting times, and then it's creating another vector called bins. Okay, well, what is bins? It's the result of running the seq command, making a sequence with the lowest value equal to the minimum of x, the largest value equal to the maximum value of x, and with a number of elements equal to input $bins plus 1. What's this input $bins? Well, whenever we see an input $, that's referring to something that we set up in the user interface, something that the user is going to specify. So actually going back up, we see that the bins label is associated with the slider input. Going back to the app itself, the input $bins is being chosen by wherever the user puts the slider. So it would equal to 45 here, it would equal to 13 here. So input $bins is actually automatically being extracted out whenever the user interacts with the app. And so that's how the bins vector gets created. Okay, well, now finally, we're on the line of code that creates the histogram itself. Histogram of x, waiting times in this case, breaks, which tells us where the start and end location of the bars of the histogram are, is equal to bins, this vector that was just created, which is drawing its appearance from how many bins the user has selected. Then we have the color of the histogram itself, right now of dark gray, and border of white. So how can we change the title and the x-axis? Well, we can add additional arguments to the hist command. So I'm going to add a comma because I'm adding in a new argument, and I'm going to say xlab equals, this is my spot for saying what that x-axis is going to be. So this is the waiting times, and to change the title, the argument is actually main equals. And we'll just call this histogram of waiting times. So once we've made that change, I'm going to save it. I'm going to click Reload App. And when I head over, I see that indeed the title and the x-axis has been changed. Okay, well, that's all well and good. What if I wanted to allow the user to choose between looking at the waiting times and the eruption times? That's another column of data in the faithful data frame. So maybe I'd like to add in a spot in the UI elements that allows the user to select which column is going to be examined. So whenever I want to add a new feature to the UI interface, the interactivity, one thing I like to do is to head over to the cheat sheet and see, well, which interactive element would I like to have. So as I scroll down, one thing that catches my eye are these radio buttons. Maybe I could add some radio buttons where the user clicks either on eruption time or on the waiting time. So if we want to add in a new interactive element, that's going to take place up in the UI part of the code. And what we're going to do is add in an additional argument to this sidebar panel. That's what's controlling the layout, kind of where the plots are, where the interactive elements are of the app itself. Right now we have the slider input. I'm going to add in an additional argument, an additional feature to have in the interactive part of the app. So because I'm adding in a new argument, I'm going to separate that first argument from the second with a comma. And I'm going to start typing out radio buttons. That was the name of the function that's going to create those radio buttons from the cheat sheet itself. We just have to figure out, okay, how are we going to set this up? Well, here's how we set up a new UI element. The first argument is just going to be the name that we're assigning internally to this UI element. So when we do input $bins, that was extracting out whatever the user had selected for the number of bins. So I just want to come up with a name so that I could refer to it later on and have the plots and the other parts actually refer to the value that's been set in by the user. So I'm going to call this variable choice. Does that make sense to me? It's up to me what I want to choose this name to be. I'm going to call it variable choice. The second argument, we go and look at the cheat sheet. Input ID is what we just specified, that internal name, how we're referring to it. Label is just going to be the title of that interactive element. The title of the slider was called number of bins. The second argument was number of bins. So we're just going to come up with a title for that radio button. So we can say choice of variable. Looks good. Now, what else do we need to add? Well, looking back at the cheat sheet, we need to give it a listed choices and a default choice. So choices and selected. So let's go ahead and do that. Let's move on to the next line and say choices equals, and we'll pass it a vector of what we want displayed. So we can say either waiting times or eruption times, however we want it to be displayed. And then we want to have what is selected by default. So we can say, well, let's just have waiting times be selected by default. I'm going to save this and click Reload so we can see how the app has changed its appearance. So we now have a new interactive element, choice of variable, and I can select between waiting times and eruption times. Now notice the app isn't changing as I'm going back and forth, and that's because I'm not actually utilizing what we're selecting here as the histogram is being drawn. I haven't connected what the user is specifying for the variable choice down in the code that's actually creating that histogram. So let's do that part. Right now, the histogram is always being created from the second column of faithful, the waiting times. Why don't I go ahead and change this to be dependent on what the user is selecting based on that radio button. So I could say something like, well, if input $variable choice, that's how we drag or use what the user has selected for that radio button. If this is equal to waiting times, then, well, we can keep this as is. Basically define the x vector to be that second column. If instead, I'm going to copy and paste, if that's equal to eruption times, then I'm going to have that be the first column. I don't need that line of code anymore. X is being defined based on what the user has selected for the variable of interest. And let's go ahead and save it and click reload just to see how that happens. So when we click reload, we see that if we switch back and forth, a different variable is being plotted. But I need to make an additional change. Notice the title is always histogram of waiting times. The label is always waiting times. And I want that to be dynamic as well. I need that to be keyed in by what the user is selecting. So let's change that part of the code that was actually generating the histogram. We have the xlab and the main arguments of hist that are controlling the label of the x-axis and the title. And so let's have this automatically draw from what the user selected from that radio button. So I'm going to move this on to additional lines just to add a little bit of clarity. And so I want this xlab to be, well, if I think about it, I want that to be whatever the user selected up in variable choice. If I say xlab equal input $ variable choice, well, if the user selected waiting times, variable choice is going to be the text expression waiting times. If they selected eruption times, it's going to be the text expression eruption times. So if I just say xlab equals input $ variable choice, let's see what happens. I'm going to click reload. I'm going to save selected. I get that error. I just reload it again. It's fine. And now I see as I go back and forth, the label of the x-axis is changing. Okay, let's change the title of this. Well, I need to be a little bit clever. I still would like to have the word or the phrase histogram of. I just now want to insert waiting or eruption times based on what the user has input. And here's a great command to know about. The paste command is able to paste together text expressions to make one long text expression. So in this case, what I'd like to do is I'd like to paste together, at the start of the expression be histogram of, and then what I'd like to paste into that expression is whatever the input $ variable choice is. So it'll take histogram of and then paste it together with either waiting times or eruption times, depending on what the user selected. And so let's finish off our histogram argument with that last parenthesis. And let's go ahead and reload it. Save selected, get that error, scowl. It's fine. And now as we go back and forth, we're seeing that the title and the x-axis is changing. Great. So let's add an additional element to the app that shows a summary of what's being displayed, a summary of the eruption times or a summary of the waiting times. So if I were to say summary of faithful bracket comma 2, that's a summary of the waiting times, bracket comma 1 would be the eruption times. So how do I get that into the app itself? Well, that's where I'm going to head over to the cheat sheet and say, okay, I want to add some sort of text output. What can I draw from to actually make that happen? So here are my choices for outputs. I can make a table, I can make an image, I can make a plot, I can print out the result of some command, so that looks like what I want to do. I can make a table, just a random text expression, or even stuff that's more complicated. So it looks like the best match is going to be a render print. That's actually what goes in the server. What I need to add in as a placeholder is a verbatim text output. So just like I put a placeholder for the histogram itself as an argument to main panel, I want to add now an additional argument to main panel that sets up a placeholder for the output of running summary. So an additional argument, so I'll add in a comma, and I'm going to type in verbatim text output. And the argument for verbatim text output is just going to be a label that's going to be used internally that's able to connect that placeholder with the server code that's drawing the plot. So this name is completely up to me. I'm just going to call this summary of variable. Okay, so once I've created that placeholder, if I run that app, we'll see that nothing's happened. I've created a placeholder. It's going to come down here below the histogram, but I haven't told the server, here's how you actually make this. So let's get that code working. Well, this big chunk of code right here was all the code that was used to create that histogram. If I want to create more elements, well, I'm just going to press return a few times and add in some blank spaces. So whenever I want to add in something new that's being displayed in the app itself, I'm going to say output $, and then specify, okay, well, what placeholder am I referring to? I set up a placeholder called summary of variable. I'm going to do output $summary of variable. And then I'm going to left arrow that to the function that actually creates the visual display. Now, going back to the cheat sheet, if I set up a placeholder to be verbatim text output, I need to render that image or render that visual with a render print command. So just like that plot output was able to actually create a histogram with the render plot command, I'm going to use that render print to help me out here. So render print, parentheses because it's a function, and I'm going to put in curly brackets because we're going to be passing in a whole chunk of code as the argument to our function. So what do we need to have happen? Well, we just need to print out the summary of whatever variable has been selected. Now, I already wrote some code that automatically figured out, okay, here's a vector called x that's tied in to what the user has selected, so I'm just going to copy and paste this. If the variable choice was waiting times, x will be the second column. If it's eruption times, it'll be the first column. And so I can just say summary of x in this case. All right, let's save it. Let's reload the app. And let's see what we end up getting. So that placeholder adds in that summary right below the histogram. What's being displayed? Well, the result of running summary on whatever column we're looking at. Now, notice that this isn't the most useful display because we don't really know what this corresponds to. We know the histogram deals with waiting times, but maybe it would be helpful to add in a label, maybe either above or below the summary, that lets us know, hey, I'm looking at a summary of this particular quantity. So can we add in a label up here, kind of in between the histogram and the output of running summary, that lets us know what this output corresponds to? Well, yes. Let's go over to the cheat sheet and figure out what do I need to add here. So in this case, I really just want to add in some text. So I'm going to render some text above the output of summary. I need to declare a placeholder in the UI function called text output, and then I'll create that text with a render text function. All right, so let's set up the placeholder first. That's going to be text output. And the ordering in the main panel, the ordering of these arguments, tells you the ordering that you see it on the app itself. So I'm going to add in a text output in between the plot output and the verbatim text output, the plot and the summary. So I'm going to call this just a useful label because that's what it is. I'm going to add a comma to the end of that because each argument of main panel needs to be separated by commas. So now I've put in a placeholder for where that label is going to be, and now I just want to add in what that label is actually going to look like. So I'll add some more blank lines, and whenever I add in some new display to the app, it'll be an output $, whatever the name that I gave to it internally back up in the main panel. So in this case, useful label. I'll copy that. And I'm going to render something. Go back to the cheat sheet. Render text goes with text output. So we're going to render text here. Parenthesis, curly bracket, and what do we want this to read? Well, if I think about it, what would be useful is to basically see the expression, summary of whatever variable that I'm currently looking at. So let's use that paste command to paste together that expression once again. So back when we looked at the histogram title, we pasted together the expression histogram of, and then whatever the user had selected from the radio button. That seemed like pretty good code, so let's reuse that here. Let's just say paste summary of. So paste, basically print something out to the screen. Let's see if that works. Let's save it, and let's reload the app. Go find that app. And boom, there we go, summary of waiting times. Maybe I'd like to add in a colon to the end of waiting times, just for illustration. So I can continue to add in additional arguments to paste after I see expression, or the expression for the waiting times or eruption times, if I just add in quotes a colon, save, reload, what we find is that that's added that colon. So great, if I change this, I get a nice helpful label that says summary of waiting times or eruption times. So making some good progress here. How about if I add in one additional display, maybe a scatter plot below this summary that looks at the relationship between the waiting times and the eruption times? All right, well, if I want to add a plot, I just got to figure out how do I declare the placeholder, how do I actually get the server to draw it, and if I want to plot, the placeholder is going to be called plot output, and the render function that makes that plot is going to be render plot. So let's set that up. I want the plot to be underneath that summary, so I'm going to add a comma and then a plot output. So I'm just going to call this scatterplot because that is what we're going to be creating. Once again, this name is completely up to me. Make it informative. We're going to call it scatterplot. So plot output reserves that area of the app to make that plot. And now just in the server function, I need to go and make that plot. So I'm going to say output $, and then however I'm referring to it internally, scatterplot, is going to be the result of running render plot. Render plot actually makes the plots in the app. So we have the parenthesis, we put the curly bracket, and then put all the code that's going to make that plot for us. So what do we want to do? Well, we want to run the plot command, and we just got to figure out, okay, well, how are we going to make this plot command go? Well, why don't I go ahead and create a y vector that's going to correspond to the y-axis of the plot. So y is going to be, let's say, the eruption time. Let's imagine we want to kind of see how the eruption time depends on the waiting time. So my y variable would be faithful, I'm going to say $ eruptions, and my x variable is going to be faithful $ waiting time. So when we make this plot, the vector y is going to be defined to be the eruptions, the vector x is going to be defined to be the column for waiting times, and I'm going to plot y twiddle x. So I'm going to press save, reload the app, go look at the app, and boom, there's a scatter plot. Great. Now, I want to add in some helpful labels, so let's do that. We'll add in some additional arguments to plot. So we have xlab equals the waiting time. Ylab is going to be the eruption time. Save it, reload it, find it. Now we've updated that. So one last thing, just to add in a little bit more functionality, let's add a checkbox that allows the user to swap the role of these eruption and waiting time axes. So, okay, I want to add in some sort of checkbox in the cheat sheet, in my list of inputs. What seems to do the trick? Well, here's the checkbox right here. I'm just going to have a single checkbox here, so a checkbox input is what I want. I'm going to highlight that. I'm going to copy, and I'm going to paste that back up into where I've been adding in the UI elements. So I have a slider input, I have a radio button. I'm going to add one more. So I'm going to add a comma at the end of radio buttons and paste checkbox input. First argument is that internal ID. It's however I want to refer to it. We'll do axis choice. I know where I'm choosing what's on what axis. That makes sense to me. What do I want the display, the title of that interactive element to be? Well, we can say flip axes, a little question mark. And the value, honestly not sure what that does. Let's delete that and just see what comes up. So we have something for flip axes. I can check it. It's not doing anything right now because, well, it's not connected to how the plot's being made. And so, all right, we just got to figure out how do I incorporate what the user has done with this checkbox to change the appearance of this plot. Okay, now here's where I actually need to go look up something because I'm not exactly sure when the user checks this box what variables get set to what. How can I actually use the result of what the user has checked. So in the widget gallery, we see all the different user elements we can add to our app. And what's great about it is that we can actually look to see, well, what's the code behind this? So in this case, I'm doing a single checkbox. You'll notice that if I check and uncheck this, what ends up happening is that the variable that's being stored into that internal reference name that I came up with is just true or false. So I'm going to use that in order to figure out how I need to change my code. So essentially, when the user clicks that checkbox, input $axis choice is going to be equal to true. If the user doesn't have it checked, it's going to be equal to false. So, all right, let's go back down to the scatter plot and let's incorporate this. So if input $, how am I referring to it? Axis choice. If this is equal to false, then I'm going to have this chunk of code just run as is. I'm going to have y be the eruption times, x be the waiting times, and make the plot accordingly. If instead they've checked that box, I'm basically going to do the reverse. I'm going to copy and paste this code, but then just change what x and y is defined to be. So I'll still plot y twiddle x, but now the y label is going to be the eruption time, or the x label will be the eruption time, and the y label will be the waiting time. So I'm going to click save. I'm going to reload that app, go find it, and let's see. So right now, eruption time versus waiting time, flip the axes, check it, boom, waiting time, eruption time. So that's going to be independent of what's been selected up here. So that's just changing the histogram, that's changing the summary, the bin's changing. So, cool. We did steps 1 through 7, tasks 1 through 7, and now we have a pretty fine looking